Title: Crash Course Instrumentation Episode 27, Temporary Connections and Prototyping Tools. Welcome to Episode 27 of Crash Course Instrumentation. This is the third and final episode in our series on conductors and electrical connections. We've already covered permanent joints like splices and crimps, but in this episode, we focus on the tools and techniques used for temporary connections and circuit prototyping. In this episode, you'll learn what makes a connection temporary. Temporary connections are designed to be easily reconfigured, disconnected, or reused. They're commonly used in troubleshooting, teaching labs, prototyping environments, and test setups. Unlike permanent terminations, these are optimized for speed and flexibility, not longevity or mechanical durability. According to NEC Article 590.3, temporary electrical power and lighting installations shall be permitted only during construction, remodeling, maintenance, repair, or demolition of buildings, structures, equipment, or similar activities. These installations are generally limited to 90 days, unless extended by special permission. OSHA 1926-405A2 also defines temporary wiring as acceptable only during construction or repair work, provided it meets the same safety standards as permanent installations. All temporary wiring must be removed immediately upon completion of the project. Common temporary connection tools. 1. Alligator clips, popular for their ease of use. They're perfect for low-current testing or temporary voltage taps, but they're not reliable in high-vibration environments or when consistent resistance is needed. 2. Banana plugs and jacks. These connectors offer low resistance and repeatable mating. Commonly used in bench testing and instrumentation panels, banana connectors are perfect for scenarios where circuits need to be connected and disconnected frequently. 3. Fahnestock clips. These spring steel clips date back to early electronics. They grip bare wire ends and were once standard in science classrooms. Though largely obsolete, they serve as a foundational example of reusable mechanical terminals. 4. Solderless breadboards. Breadboards use spring contacts hidden beneath plastic to let you connect components without solder. They are ideal for logic circuits, low-voltage analog designs, and instructional use. We'll also cover how to read a breadboard layout and avoid mistakes like powering the wrong rail. Breadboards are divided into rows and power rails. Rows are internally connected in groups of 5. The red and blue lines along the sides typically mark power and ground, but always verify continuity. A common mistake is assuming rails run uninterrupted across the entire length. Many breadboards split the power rails in the center. Why breadboards are ill-suited for high-frequency or high-power circuits. The spring clips introduce unwanted inductance and capacitance, which can distort high-speed signals. Their contact resistance can also fluctuate under load. Breadboards are rated for currents around 1 amp maximum and are not designed to dissipate heat. We explain why perfboard or soldered prototyping is preferred for high-power applications. How to build your own temporary test leads. With just a pair of banana plugs or alligator clips and some 1822 AWG flexible wire, you can create custom leads for voltage measurements, signal injection, or circuit bypassing. Add heat shrink for strain relief. Keep sets color-coded and labeled for polarity and function. Best practices for documenting changes during prototyping. Use a project log, photo documentation, or circuit diagrams to keep track of what changes were made and why. Label jumpers and add sticky notes or wire flags to indicate function. This becomes especially important when debugging or handing a project off to someone else. Fun historical note. Fahnestock clips were patented in the late 19th century and widely used by experimenters, telegraphy operators, and early radio hobbyists. Even Thomas Edison's labs used them for easy component swaps. They helped democratize prototyping by removing the need for specialized soldering tools. Want to take your prototyping up a level? Let's go beyond breadboards. Perfboards, perforated boards. These are rigid boards with a regular grid of holes, often plated with copper pads. They allow semi-permanent soldered prototypes and are great for circuits that have passed breadboard testing but aren't ready for a PCB. B. Wire wrap socket. Wire wrapping uses a tool to tightly wind a solid wire around a square post, creating a gas-tight, reliable connection. It was once the standard in telecommunications and aerospace because it was vibration-resistant and reworkable. C. Point-to-point wiring. This technique directly connects components without a board, using wire and terminal strips. It's still used in boutique audio gear and RF circuits because it offers excellent performance with minimal stray capacitance or inductance. Whether you're testing a signal path, mocking up a control circuit, or teaching fundamentals, understanding these tools makes you more versatile and resourceful as a technician. Watch all episodes youtube.com at Crash Course Instrumentation. Join the conversation www.facebook.com/groups 172542290473751. All instructional models used are courtesy of Tony Coupalt and the open-source ModL project, https://ibiblio.org/Coupalt Socratic Model Index. HTML.